Alright, today we're going to look at using slope to prove if lines are parallel or not. So we know that if two lines are parallel, they have the same slope. And we know if two lines are opposite reciprocals of each other with their slopes, then they're perpendicular. So we're going to now work on calculating using slope. So let's review slope really quickly just to make sure from last year, if we still remember. Let's graph the points, or the line that goes through the following points: -2, -1, and 4, 3. So I'm going to go over, I'm going to plot -2, -1. Let's put a dot right there. And then I'm going to go over to 4, 3. And let me draw a line between those points with a ruler. Alright, so most of you probably remember this from last year in algebra, so that's why I'm going over it a little bit faster than normal. But when we're dealing with slope, slope is the rise over the run when you're comparing the distance between 2 points on a line. So rise is how far up or down you go, and then run is how far to the right you're going. We always look at these pictures going from left to right like you're reading. So I'm always going to look on this side and then going to the right. So this line I see is going up from left to right. So let's take a look and see if we can calculate the slope. So to calculate the slope, we make a slope triangle. So I'm going to try to match the colors here. To get from this point to that point, I have to go up. And let's see, I go up 1, 2, 3, 4 spaces. Then, to get over, I have to go over 1, 2, 3, 4, 5, 6 spaces. 4 over 6. So in this case, the rise over run is 4 over 6. Remember, on your calculators, you can simplify the fractions. So let me pull out my calculator here. To simplify a fraction, you type it in, 4 divided by 6, and hit enter, and you get this decimal. To turn it back into a fraction, hit the math key, and then choose that first option there, and hit enter. So 4/6 reduces into 2/3. Okay, so that was one way of learning of doing slope, was using a slope triangle. That method always works. You can always use the slope triangle if you wanted to. There is a shortcut though, so let's look at the next part. Instead of having to graph points each time to find slope, you can use a formula. Let's use the previous example's numbers to see if we get the same answer. So we're using these same coordinates, and we're going to look at the rise over the run. Really what the rise is just your change in y's. It's a difference in the y values divided by the difference in the x values. So there's a formula, the slope formula. You take your y values and subtract them, divided by your x values, and subtract it. And we use these little subscript numbers here just to help us distinguish which y values we're pulling from. So I have y2, y1, x2, x1. And what that comes from is over here, I'm going to label, because remember all your coordinates are x1, y1, or x's and y's, right? So this first x value is my x1, this first y value is my y1, x2, y2. It's just distinguishing and separating them from each other. And now I'm going to plug these values into my formula. So I take y2, which is 3, minus, notice the minus is there, a -1, divided by x2, which is 4, minus x sub 1, which is -2. So doing these separately, 3 minus a -1, I put that on my calculator, 3 minus a -1 is +4, over 4 minus a -2 is 6. So we get that same answer that we had above, and we already know this reduces into 2/3. So we can use this formula to calculate the slope between points. Here's the official formula. If you have a line with 2 points on it, and you're given those 2 points, you label them as x1, y1, x2, y2, and then do the change in y's over the change in x's. Because really that's all you were doing when we did the rise over run up here, when you were counting. You were looking at the difference between this y value and this y value, which was 4, and then the difference in the x values, which was 6. We're going to use that now to help us with our parallel line stuff. So flip it over. So we can now determine if lines are parallel or perpendicular by finding the slope between the given points. So let's try a couple of examples. We're going to use the slope formula to determine if the lines are parallel, perpendicular, or neither. We're going to graph the lines to check to make sure that they aren't the same line. So what they're giving us some points, and they're giving letters to those points. They're saying a equals 1, 2. So if I plotted it onto a coordinate system, it'd be 1, 2. B is -1, -2. C is -2, 0, and D is 0, 4. And it's saying if I put a line between point A and B and a line between point C and D, is there a relationship? So remember, we can test that right away. We know parallel lines should have the same slope, and perpendicular lines have opposite reciprocals. So different sign, and they should be flips of each other. So let's find the slope between the first 2 points here. And remember, our formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So using the first set of points that they give us, a and b, because a and b are the ones that they put together on the line, I'm going to use my formula. This is x1, y1, x2, y2. So plugging it into my formula, -2 minus 2 over -1 minus 1. And that gives me -4 over -2, which when I divide gives me +2. So my slope between these 2 points is 2. Now let's do it again with the other points, and I'm going to use a different color so I can separate. C and D, same idea, x1, y1, x2, y2. Let's take my values. y2 minus y1 is 4 minus 0 over 0 minus -2. So it becomes 4 over 2, which turns into 2. So based on them having the same slope, these lines are parallel. And now we can graph it just to make sure that it's not the same line. So I have 1, 2 is A, and -1, -2 is B. And then 0, 4 is D, and -2, 0 is C. So you're probably asking, why can't I just graph the lines in the beginning to see if they're parallel or not? And the issue is you can't always just tell by the way it looks. You have to actually do the math. Alright? So let's try the next one. Given these points, let's determine if these lines are parallel, perpendicular, or neither. So it says EF, so I'm going to compare E and F. Remember, your slope formula is y2 minus y1 over x2 minus x1. So label your coordinates x1, y1, x2, y2, and then just plug them in. -7 minus -4 over -1 minus 0. So I get -7 plus 4. Again, if you're having trouble with this, use your calculator. Just type it in exactly as you see it. It gives me -3 over -1, which is 3. To compare the other points, I do the slope formula again between these points. So I have x1, y1, x2, y2. So I have 2 minus 0 over negative 3 minus 3. 2 minus 0 is 2. Negative 3 minus 3 is negative 6. Let's simplify that though. 2 divided by negative 6 gives me that weird answer. Hit math, fraction, and it gives me negative 1/3. So these slopes are opposite reciprocals, so they're perpendicular. For perpendicular lines, you don't need to graph them because they're not going to be the same line. It's only for parallel lines that you'd have to graph. Try example 3 on your own and see if you can get that, and then work on the practice problems for today.